How can we work out 5 to the power 7 divided by 5 to the power 3? I can work out that using the long way, so I'll call that method 1. So that will be 5 multiplied by 5, multiplied by 5, multiplied by 5, multiplied by 5, multiplied by 5. 1, 2, 3, 4, 5, 6, 7 over 5 multiplied by 5 multiplied by 5. Now, we know that 5 divided by 5 is 1, which means that if I divide this 5 and this 5, I'll get 1. This one and this one, I'll get 1. This one and this one, I'll get 1. So what I end up with here is I'll end up with 5 multiplied by 5 multiplied by 5 multiplied by 5, and this is just 5 to the power 4 because I'm using 5 in this multiplication 4 times. So that's method 1. Method 2 is just based on looking at this pattern. So let's look at this connection. What we have here is 5 to the power 7 divided by 5 to the power 3. So instead of doing all this, we can just subtract the powers. 5 to the power 7 minus 3, which will be 5 to the power 4, which is the same answer as what we have on the left. So you can generalize and say that if you have a to the power m divided by a to the power n is the same as a to the power m minus n. And that's a very important result. So let's look at this example here. The first thing you need to do is set it out. So you'll have 12 a to the power 5 divided by 3a squared. I'll write this way. So 12 multiplied by a to the power 5 over 3a squared. Now I'm going to focus on these guys separately and those guys separately. So 12 divided by 3 is 4, not a problem. Now here, because we are dividing these guys, you are going to subtract the exponents or the powers. So we'll have a to the power 5 minus 2, which will give us 4a to the power 3 as our final answer. Next, we have 18 z to the power 6 divided by 3a. So the first thing is we need to set it out. Same thing. So 18 z to the power 6 over 3z. I'll rewrite this way. So 18 multiplied by z to the power 6 over 3 multiplied by z. Now, if you just have z by itself, we can write that as z to the power 1. So the first thing is I'm going to focus on this guy separately and on the z guy separately. So what I'll end up with is 18 divided by 3 is 6, and then multiplied by, now for the z guys, because I'm dividing them, I'll just subtract the indices. So 6 minus 1, which will give me 6z to the power 5. Here is another question. How can you work it? How can we work it out? So what I'll do here is I'll start with these guys in the numerator. So this will be equal to, in the numerator here, we have x to the power 3 multiplied by x to the power 7. And we know that if you have a to the power n multiplied by a to the power n, it's equal to a to the power n plus n. So we just add them up. X to the power 3 plus 7 over x to the power 10, which is just x to the power 10 over x to the power 10. Now you're dividing x to the power 10 divided by x to the power 10 is the same as dividing something like 1,000 divided by 1,000. You know, you get just 1. Even if you have 81 divided by 81, you just get 1. So this will just be equal to 1 because you're dividing by the same thing. So, and that will be our final answer there. Next question. So we'll start by setting it out. But before we do that, you can also start maybe by focusing on the numerator. Let's simplify the numerator first. So what we'll end up with here is 18 multiplied by 20 multiplied by r cubed multiplied by r to the power 12 over 6r to the power 9. Now here what we have is, we have, you know, whole numbers which you can multiply. We also have these guys which you can multiply. So what we'll end up with is 18 multiplied by 20 is 360 multiplied by r to the power 15. In the denominator we have 6 multiplied by r to the power 9. Now that's when I will start focusing on these numbers and those by themselves. So what we'll end up with is 360 divided by 6 will give us 60. And then because you're dividing these guys, we'll subtract the indices. So 15 minus 9, which will give us 60r to the power 6 as our final answer.